This is Math 2 3.3C and D, combining two sets of notes today in this one lesson. So we're going to put this 3.3C and D together in class. Okay, bisect. And the part E that we're doing in class will be perpendiculars. All right, number one, we're going to talk about bisectors and what does it mean to bisect, just like it sounds like. Bisect cuts things in half. So a segment bisector will cut a line in half, and an angle bisector will cut an angle in half. All right, let's try some. Or one, given QT bisects angle PQR and angle PTQ is congruent to angle RTQ. Again, without the picture, that doesn't make sense. I've said that before in class and in other sets of notes. So we are going to draw our image now. This is PQRT. Okay, I will mark the given information in pen and what we can come up with in the picture in pencil. All right, what we are trying to prove is that triangle PTQ is congruent to triangle blank. All right, given information, QT bisects angle PQR. Okay, I'm not going to mark that because it's just, it bisects. Angle PTQ, that's this angle right here because T is the vertex, is congruent to RTQ. Okay, so these two angles are congruent. Now, I know because of reflexive property, I'm going to mark this in pencil, that QT is congruent to QT. And I also know that these two angles are congruent. How do I know that? Because we can't just randomly put angle markings. I know that because this QT right here, QT bisects, means it cuts in half angle PQR. If it cuts PQR in half, then these two segments are congruent to each other. They're equal. All right, let's try to put together our proof statement, reason. Number one, always the given information, QT bisects angle PQR. Angle PTQ is congruent to angle RTQ. And all of that is because it is given information. And I should have been writing in pencil. Number two is what did we come up with? It doesn't matter if you put the QT first or the angles are congruent. I'm going to do the angles first because that was right here part of the given information. QT bisects PQR. Now, that was given. It didn't say those two angles are congruent. We came up with that with the given information. So angle PQT is congruent to this angle here, so that's RQT. And why is that? Definition of not a segment bisector, but an angle bisector. Definition of an angle bisector. An angle bisector cuts an angle in half, which makes these two angles there congruent. All right, number three is not the ending yet because we don't have enough information yet to say the triangles are congruent just with these two sets of angle markings. I also need this side here, which is QT, is congruent to QT. That's a review from a previous lesson, and that's because of reflexive property. All right, Now we have enough information to say the two triangles are congruent. And I'm hoping you can see why. I have an angle marking, a side marking, and an angle marking. And the side is sandwiched between the two angles. Angle, side, angle. If you look at one at a time, you can see that. Angle, side, angle. Angle, side, angle. All right, so I'm going to put that there, angle, side, angle. The two triangles are congruent because of the angle, side, angle congruency. And we're going to say triangle PTQ is congruent to triangle what? Let's see, PTQ. No angle marking, one angle marking, two angle markings. None, one, two. None, one, two. That's RTQ. And I'm going to fill that in up here as well, RTQ. All right, and we'll do more of those together in class as well. Number 2, you know what parallel lines are, two lines that go on forever and never intersect. And we've talked in class about alternate interior, same side interior, corresponding angles, and stuff like that. Okay. Given PQ parallel, that's the shorthand for parallel, PQ is parallel to TR, and QR is parallel to PT. Prove triangle PQR is congruent to triangle blank. All right, let's get our image. I'm going to draw over here a parallelogram looking quadrilateral. And I'm going to draw a diagonal across this way. And we're going to go ahead and label Q, R, T, P. All right, what is the given information? PQ, that's this one here, is parallel to TR, that's this one there, and QR, top one, is parallel to PT. All right, opposite sides are parallel. So that means it is a parallelogram. All right, what are we going to do? We need to prove that PQR is congruent to what triangle? All right, what markings can we now add? Well, this one's the obvious. PR is congruent to PR because of reflexive property. Now, think of your Z shapes. We've talked about that before. I'm going to do PQ first. If this line is parallel to this line and it has this line going there, the transversal, can you see the Z shape? Okay, it's a backward Z, but it's still a Z. That means that these two angles here are congruent. And what do we call those? We call those alternate interior angles. All right, let's see if I can get my second Z shape in there. QR is parallel to PT. Now, this transversal is going across this way. I have another set of congruent angles. That's this corner and this corner. This Z is not backwards this time. So that corner and that corner. All right, those two angles are congruent because alternate interior angles are congruent when lines are parallel. All right, let's see, my pencil marking in here kind of got lost. Can you see that we now have enough to say the two triangles are congruent? I'm going to cover that piece there. Can you see it? Angle, side, angle. We don't jump across. Kids will say, oh, angle, side, and jump across that way. That's not how it works. It has to be in the same triangle. There's an angle, side, angle there. And if you looked at the bottom piece, there's an angle, side, angle there. Okay, so we have enough to say the two triangles are congruent. Oh, sorry. Let's statement and reason. Number 1, always the easiest piece, PQ is parallel to TR, and QR is parallel to PT. I'm just using that from right up here, and that's because it is given information. All right, number 2, or I'm going to put the angle markings that we have in there. I'm going to start with the single angle marking. So that corner and that corner, I cannot say P is congruent to R because there's multiple angles in corner P as well as in corner R. So if I'm talking about this one right here, P is the vertex, so Q, P, R, not T, P, Q, R. If I said T, I'm talking about the bigger angle. But I want the smaller one, P, Q, P, R. Angle, Q, P, R is congruent to angle. I want to talk about this single one here. So that's going to be TRP or PRT. Okay, TRP. And why are those two angles congruent? Don't just put alternate interior angles are congruent, because not all alternate interior angles are congruent. They're congruent because these lines are parallel. So we put parallel marking, arrow, alternate interior angles are congruent. And that's how you're going to mark it from now on when you want to talk about alternate interior angles being congruent. You'd say the lines are parallel, so alternate interior angles are congruent. That's about as shorthand as I'm going to allow it. Okay, now I'm going to talk about these double angle markings there. These two are congruent because these two lines are parallel, the red ones. So you have a choice. You can call that number 3. I'm going to stick with number 2 because it's the same reason. Because the lines are parallel, alternate interior angles are congruent. So I'm going to say angle, let's see. I want to talk about the double one. Q, let's see, where are we at? QRP, QRP, that's this one right up there. QRP is congruent to this double one here, TPR. Angle QRP is congruent to TPR, and the first one was QPR is congruent to angle TRP. All right. And I just I combined it here with this one because they both have the same reason. It's because the lines are parallel, alternate interior angles are congruent. Two different parallel lines, these two, the two reds versus the two blues, but it's still the same reason. Now, if you wanted to call this number 3, then over here, number 3, you would have this same thing again. Your choice. All right, since I put all in one, I do have a number 3 now, and I have not said anything about this side being congruent, and I need to. So that's PR is congruent to PR, and we should know that one already. That's because of the reflexive property. And that leaves us with our last one, which is that the two triangles are congruent. So we've said earlier, look, there's an angle, a side, and an angle. And angle, a side, and an angle. So it's angle, side, angle again. Angle, side, angle, congruency. Okay, so we can say triangle PQR, they gave us the first one, we have to use that order, is congruent to triangle blank. Let's see, PQR, I went from 1, none to 2. 1 marking, no markings, 2. 1, none, 2, 1, none, 2. RTP. And I'm going to put it up here as well, RTP. Okay, we're going to get more practice like this in class. That's it for this lesson.